Alright, we're going to look at substitution and equivalence in regards to our algebra. So we're going to look at the substitution part first. Now, to evaluate an expression or to substitute means that we replace that pronumeral that we've talked about, or the unknown, or the variable, the letter value in our term, with an actual number. So a number so that we can get a final result. So if you look at this example up the top here, it's got, for example, if A is 3, B is 4, and this expression you're given is 7a plus 2b plus 5, we substitute 3 in place of a, 4 in place of b, so it ends up being 7 times 3, which is 21, 2 times 4, which is 8, and 5. So then you add them together, getting 34. Now, an example of this in a real world sort of setting is for those of you that watch AFL football, some might not. We know that for those that do watch it and those that don't, it's pretty easy to explain that for every goal, you get 6 points, okay? So you get 6 points for every goal, and you get 1 point for a point. So if you kick it behind, you get a point. So if we were to work out the score in total, if you scored so many goals and so many points, the expression we'd have to make is 6 times x, so say 6, if you kick one goal, it's 6. Times 1, giving you 6, and then you kicked a point, and then there was plus y, we'd get an answer for that. So if we, for example, said that we had 4 goals, 3 behinds, where x equals goals, and y equals behinds, we could then work out the total score. So if you had 6x plus y, you substitute 6 into, so the 4 in as x, plus, instead of y, we now have 3. So you'd have 6 times 4 being 24, plus 3 would be 27 points in total. So that's just a real world example of what we're talking about here, okay? So what we're going to look at here is a couple of other questions. So we're going to substitute x as 3, y as 6. So in this first example, we've got 5x. Now there's no y, so we don't need to worry about the y. We're just substituting in the 3 for x, so 5. And we know 5x is the same as 5 times x, so 5 times 3 is 15. Nice, simple, easy one to start with. This one that we've got here, we've got 5x squared plus 2y plus x. This one's a little bit more complicated. So we've got 5. Instead of x, we're going to put in a 3. Sorry, that's squared. And then we've got 2. Instead of y is going to be 6. And instead of x, we're going to put in a 3. Okay? So let's evaluate these or expand them. So you've got 5 will be times by 3 squared. So 3 squared is 9. Plus, this is going to be 12. That'll be 3. 5 times 9 is 45, plus 12, plus 3. So we add them up, you got 57, you end up with 60 as your answer for that expression once we've substituted in those numbers. And we'll look at a couple more on the next page. So we've got a couple here. Now we've got, we're going to substitute a as 4, b is negative 3. So in this one, 3b, instead of b, we're using negative 3. So we'd evaluate that answer as 3 times negative 3. We know, and positive and a negative is a negative. 3 times 3, 9. Right, let's have a look at D. So instead of A, sorry, I'll get rid of that. I'm going to do this straight in because we can see the formula above it. So, instead of A, we've got 4. So that's in a bracket. B is negative 3. So they're multiplied with one another. Take away 4. Plus negative 3. So we'll evaluate this one. So 4 times negative 3 will give us negative 12. Take 4. And then you've got plus and take. So we take another 3. Negative 12. Take negative 4. Negative 16. Take 3. Ends up being negative 19. So I do want to see all you're working out with these questions. Show the steps for each of the bits that you were working out. If you can go straight from this answer to the final answer, that's fine, but I want to see this part where you're actually substituting the numbers in. Alright, let's give this one a go, where we've got 100. So you've got 100, take, in brackets you've got 10, and then for A you've got 4. What happened there? Plus 10, in brackets -3, and then the whole thing is in brackets. So, first step of working would be working at your 100 here. Take away. Now in brackets you're going to have 40 plus take 30. So 10 times -3 is 30. That's really 40 take 30. So 100 take 40 take 30, which is 10. Your answer will be 90. Alright. Okay, let's have a look at this one for H. So we've got A. So instead of A, we're going to have 4 times -3 over 3 plus -3. So we'll evaluate the top one first. So it'll be -12 over 3 plus -3. So -12 divided by 3 will give us a -4 answer. Plus take gives us take 3. Give us an answer of -7. So you got to work these through in that order so that we can actually see what we're doing. Okay. Alright, well, the next part we're going to look at is that equivalence of algebraic expressions, okay? So the next bit that we're going to look at is whether two different expressions are equivalent or if they're equal regardless of the value of the number that is substituted in for that pronumeral. So, for example, A plus B would be the same as B plus A, because if you put in 1 for A, 1 for B, it'd be the same as 1 plus 1, 1 plus 1, okay? So when we look at these sort of things, we look at two different rules that we have. So we have what we call the commutative law. So the commutative law tells us that A plus B is the same as B plus A, which I was saying before. And also A times B is the same as B times A, because we know that it doesn't matter what order you multiply two numbers or what order you add two numbers, you're going to get the same answer. Then the other one that we've got is the associative laws of arithmetic, which tells us that A plus, in brackets, B plus C is the same as A plus B plus C. So A plus B in brackets plus C. And that A times, in brackets, B times C is the same as A times B together times C. Okay? So they're the sort of things that we're looking at here. So if we look at these first two, so we've got Rx take 3 and 3 take x equivalent expressions. Now, by looking at that, we know that from looking at the laws above, there's no sort of mention of using the addition, subtraction in these laws. So we would say that it's no, but we're going to test it. So say, for example, we're going to say x is 2. So if we did x take 3 and then substitute in 2 take 3, we're going to have -1. Whereas if we had 3 take x and we do 3 and substitute in the 2, we get 1. They're different answers, okay? So that proves that they're not equivalent. Alright, we're going to have a look at B. Now just from looking at it, can we tell if they are or not? No, probably not. So let's have a bit of a look. So if we say A is 1, B is 2, and we'll test it. So if you, instead of having A, you've got 1 and 2, and that gives you an answer of 3. Whereas if we look in the other version, so the B plus 2A take A, we'll substitute 2 in for B, plus 2, lots of A, which is 1, take away 1. So you're going to have 2 plus 2 take 1, 2 plus 2 is 4, take 1 is 3. So for B, we would say yes, they are equivalent. So they're just easy ways to test these, okay? So you have a go at some of them and good luck.